Since Sweden joined NATO, its borders have effectively become the alliance's borders. It's here in the skies over the Baltic Sea and on the approaches to Finland that the effectiveness of European defense is tested.
Sweden's accession to NATO in March 2024 fundamentally altered the alliance's strategic map, turning the Baltic Sea into a NATO lake and extending the alliance's land border with Russia by over 300 kilometers with Finland's 2023 accession.
Russian aircraft without transponders, unauthorized reconnaissance flights, and now drone attacks, all of this has become a reality faced by Swedish JAS-39 Gripen fighter jets.
In January 2024, a Russian reconnaissance drone was confirmed to have violated Swedish airspace east of Gotland, a recurring pattern of aerial provocations that Swedish Gripens are tasked with intercepting and identifying.
Once designed as a light and smart fighter, the Gripen finds itself at the center of a new front. However, will they be able to become not only effective interceptors but also universal drone hunters?
The Gripen's advanced radar, sensor fusion, and ability to carry a wide array of air-to-air missiles make it well-suited for the drone hunting role, a mission set that is becoming increasingly critical in modern air defense.
In the 1980s, it would have taken any of the approximately 4,300 combat aircraft of the former Warsaw Pact countries just 15 minutes to reach Swedish territory.
This geographical reality, with Soviet bases in the Baltic states, shaped Sweden's entire defense doctrine, leading to the development of a dispersed airbase system and a highly capable indigenous fighter industry.
The main driving force in this matter was the National Defense Corporation, Saab AB, which has created dozens of military and civilian aircraft, numerous missiles, ground-based radar systems, and even submarines.
Saab's unique position as a developer of integrated defense systems, from the Gripen fighter to the Gotland-class AIP submarines and Giraffe radar systems, allows for a deeply networked and holistic national defense capability.
We are, of course, talking about the JAS-39 Gripen, a Swedish fourth-generation multi-role fighter that served Sweden faithfully since 1996.
The name JAS is an acronym for Jacked Attack Spanning, Fighter Attack Reconnaissance, reflecting its designed-in multi-role capability from the outset.
The deliberate instability of the design and the use of fly-by-wire to maintain stability also managed to remove the lion's share of the Gripen's flight limitations, greatly improving its maneuverability and reducing drag.
This relaxed stability design, where the aircraft is inherently unstable, allows for extreme agility, but is impossible for a human to fly without the constant, rapid corrections of a digital fly-by-wire system.
After all, Sweden had spent years developing the BAS-90 Rapid Access Airbase system, developed at the height of the Cold War, to make it virtually impossible to destroy the Swedish Air Force on the ground with nuclear weapons or enemy airstrikes.
The BAS-90 system involves using long stretches of public highway as dispersed runways, with pre-positioned fuel and ammunition, allowing the Air Force to operate even if main bases are destroyed.
The JAS-39 was equipped with a retractable tricycle landing gear and a twin-wheeled nose gear with single main wheels, and a pair of air brakes were positioned on the sides of the rear fuselage, while the front wings were also angled to act as additional air brakes and reduce landing distance.
The robust landing gear and short landing capability are direct results of the highway basing requirement, allowing the Gripen to operate from road segments typically just 800 meters long.
Already at the development stage, Saab sought to ensure the longest possible service life for its new fighter, setting a conditional figure of at least 50 years.
This long-term vision is evident in the Gripen EF models, which feature hardware and software architectures designed for continuous, easy upgrades, ensuring relevance against evolving threats for decades.
Not to mention, much like your smartphone, the JAS-39 can easily update its software, incorporating the latest sensors, computers, and weapons as they evolve.
This approach, often called continuous development or agile development, significantly reduces upgrade costs and time, allowing the Gripen to integrate new capabilities like the Meteor missile with relative ease.
We will see something similar a little later in the F-35 Lightning II projects and even in the American sixth-generation fighters of the Next Generation Air Dominance program.
While the F-35 also employs sophisticated sensor fusion, the Gripen was a pioneer in implementing this technology on a fourth-generation platform, demonstrating a highly advanced systems integration approach.
But the most interesting and advanced is rightfully considered the latest embodiment of Swedish engineering thought, JAS-39EF.
The Gripen E, single seat, and F, twin seat, represent a significant capability leap, often considered a 4.5-plus generation aircraft, with more power, fuel, and advanced avionics.
The new E and F modifications feature a larger fuselage accommodating 30% more fuel and General Electric F414G engines capable of producing 20% more thrust than the Volvo RM12.
The F414G engine produces 22,000 pound-feet of thrust compared to the RM12's 18,100 pound-feet, a key enabler for the Gripen E's improved performance with a heavier weapons and fuel load.
The radar's also undergone some changes. Instead of the familiar Ericsson and GEC Marconi PS05A multi-mode radar,
the ES-05 AESA, Active Electronically Scanned Array, radar provides greater detection range, improved reliability, and the ability to track and engage multiple targets simultaneously, a major advantage over older mechanical scanned radars. The IRST is a critical passive sensor that allows the Gripen to detect and track enemy aircraft without emitting any radar signals, enhancing stealth and survivability in a contested electronic environment.
In terms of armament, the current EF versions will be equipped with up to 7 MBDA Meteor BVR air-to-air missiles.
The IRST is a critical passive sensor that allows the Gripen to detect and track enemy aircraft without emitting any radar signals, enhancing stealth and survivability in a contested electronic environment.
Furthermore, in 2014, the Gripen tested the Enhanced Defensive Missile Defense Pod, the Survivability Technology Modular Self-Protection Pod.
This pod, often called the Arexis Reconnaissance Pod in its more common form, is part of the Gripen's modular plug-and-fight philosophy, allowing specialized mission pods to be swapped as needed.
After all, the Gripen is a reliably sold aircraft abroad, already operating in 5 countries and regularly receiving additional orders.
As of 2024, the Gripen is in service with Sweden, South Africa, Czech Republic, Hungary, Thailand, and Brazil, with new orders from countries like the Philippines being finalized.
Just this summer, Saab announced successful test flights of its Gripen E equipped with the Centaur artificial intelligence system from German company Helsing, capable of autonomous air combat.
These tests, part of Saab's Beyond project, represent a major step in integrating AI as a collaborative combat partner, not just automation, to reduce pilot workload and enhance decision-making in complex BVR engagements.
During the testing process, Centaur rapidly gained experience and decision-making skills for BVR combat in a combat arena described by Saab as playing chess in a supersonic with advanced missiles.
This use of AI allows for the rapid synthesis of vast amounts of data from the aircraft's own sensors and off-board sources, like AEWC, to develop optimal firing solutions and maneuvers far faster than a human pilot could alone.
Saab also confirmed that the Centaur has the capability to expand air combat to within visual range, WVR. This is a top priority for the team as WVR remains the most critical aspect of air combat today.
WVR combat, or dogfighting, is immensely dynamic and difficult to automate. Developing AI that can reliably perform here is a much greater challenge than for the more procedural BVR realm.
Given the latest news and repeated provocations by Russian drones crossing Sweden's borders, it's worth repeating once again that the Swedes have once again anticipated many of their European allies in this matter.
Sweden's long-standing policy of total defense and its historical position on the front line of the Cold War have fostered a culture of pragmatic innovation, allowing it to anticipate and prepare for emerging threats like drone warfare.
And even if the Centaur ultimately doesn't receive funding for installation in the entire Gripen fleet, the experience gained by Saab and Helsing will likely find its way into the future Swedish fighter development program.
This AI development work is directly applicable to the Swedish-British-Italian Global Combat Air Program, GCAP, to develop a 6th-generation fighter, ensuring Sweden retains its cutting-edge design and systems integration expertise.
You think the Swedish Gripen can compete with the American NGAD fighters thanks to its modularity? Or will it need more than just AI on board to do so?
While the Gripen's modularity and AI are significant advantages, the U.S. NGAD program is envisioned as a system of systems involving a 6th-generation crewed fighter, advanced drones, and space-based assets representing a different scale of ambition and capability.
Let us know in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's.